Hey guys, welcome back to the channel. This is episode 2 of the C1500 truck build. We got some cool stuff done last week. After the last video you saw go out, first thing we got done was the cross members done. So got the top plate all welded up, everything's seam welded out. We'll go over a little bit of details about some of the lower control arm mounts, as well as the steering rack, what we got going on there. My buddy Calvin helped me out with some machining of risers and stuff like that, and basically some of the design considerations that went into that. We also got this bad boy in. This is the JD Square Model 3 bender, and I'll go through sort of like an unboxing, not really an unboxing, it's after it was already set up, so you can sort of see how the thing is set up. If you're looking at one, we'll be testing it out on this build. I'm new to tube bending, so we'll learn together. And if you're looking at one, I'll let you know if it's worth the buy. So far, it's beefy. We also got done some work over here on our lower control arm fixture. So this is a lower control arm fixture. This is actually the second one that I cut out. And if you follow Instagram, you probably already know why. But this basically setup is sweet. So what we got going on here is we 3D printed out some brackets, if I can get these to index, and they have these little receiver slots on the bottom that make everything snap into place here. And this gives you a really good positional hold on where everything needs to be mounted up for the lower control arm. So the goal of this is we're gonna get this all set up and get our tubing bent and get everything sort of laid out the way we want with these clamps. Like you can see here, and there's a whole bunch of them, which I don't need to go through right now. But we're gonna get these sort of laid out and use this as our fixture for tacking up our components, and it'll keep our control arms positionally accurate. So I hope you guys enjoy the video today. I have some parts coming in for next week when we're actually going to try to get into bending up the lower control arms and get that kind of stuff going. But overall, I hope you enjoy the video. Take care. Okay, so what we got is a Fox Body Mustang manual quick ratio rack. Now the rack is manual, the truck will not be. I'll be using an electric steering column, power assist steering column. Probably not sure which one I want to use yet, but there's a couple different factory options that are pretty affordable that we're going to try to use. What we did was 3D printed up some spacers here to see where we're going to fit. So I fitted these up. These are a little too long. We're going to be using a Willwood Pro spindle. So this puts me at a pretty good point where I have a decent amount of Ackerman gain, and I don't have a good amount of shaft clearance. So what we did was we transcribed the measurements of that rack, which was a pain in the butt to get, onto this cross member that we welded up. And now we're just going to go ahead and drill out some pilot holes, and then we're going to drill out a clearance hole here. This is a 0.6 millimeter drill, or 0.6 inch drill bit. So that'll give us a little bit of clearance for our bolt holes, and we should be good. So we're going to go ahead and drill this up and hopefully get this finished up tonight.
All right, so as you can see here, we got the holes drilled out, and what I did is I went ahead and 3D printed some brackets and put the rack up about where it belongs. And when you look at the position of the rack, everything works out pretty well here as far as steering shaft clearance. It doesn't look too absurdly out there, and the general location of the rack right now is determined by the spindle and the steering arm location. So I'm not going to get into Ackerman and thrust loading of the tie rods and everything like that, but it's usually ideal to have the steering rack about level with the steering arms or slightly behind the steering arms. Moving it forward and back changes the amount of Ackerman gain that you get with the geometry, the front suspension geometry, as you go through the steering stroke. But for this particular design, I'm not going with a true Ackerman. I'm going a little under a true Ackerman, or 100% Ackerman, to give me some different slip angle on the inside tire during steering. So There's some tuning things that you can do there depending on your tire sizes, what kind of tire you're going to run, etc. But for this design, I'm going to start right about 50% Ackerman, and with a little bit of shimming and changes to the steering arms on the rack, I'll be able to adjust that the rest of the way, and I can go from, say, parallel steer to true Ackerman, all within the same design by moving those steering arms in or out on the spindles a very slight amount. And with the Willwood Pro design, that's very easy to do because, well, they're a bolt-on design and the arms are basically machinable, making it very nice and easy. But thanks to Calvin for busting out these aluminum risers, getting rid of the 3D printed one. Got those installed, looking good. After that, went ahead, cut the tubing for the lower control arm sleeves, got those welded in nice and pretty, and then went ahead and got everything laid out here. And then I got the bright idea that, hey, I should probably ream them out because they probably warped a little bit. So this is me attempting to ream out the lower control arms guides with a hand drill and a 5/8 inch drill bit. Pro tip, don't do it this way. I almost broke my wrist like 4 times. So, learn from my mistakes.
Three hours later.
So I just got done recording that other video and I heard my doorbell ring, and look what we got here. So what we got is a JD squared Model 3 tubing bender, and we have a 1 1/4 inch die on a 4.5 inch center line. So this is what we're going to be using to bend up the cage as well as the lower control arms. So as we go forward with doing a lot more than just a front cross member, there's going to be a need to start doing some tubing work, and I figured why not get a nice JD square bender. So we're going to start unboxing this and get this 1 1/4 inch die installed in it. I'm going to use some of this plate steel and maybe some tubing to make a base for the unit, and might anchor somewhere on this concrete floor. We're going to put anchoring points that we can quickly remove the bender as needed. But I don't know, maybe we'll do that. Maybe we'll mount it to this table. It really depends on how much leverage I'm gonna need to move this thing if I ever wanna convert it to hydraulic. I just don't know yet. So let's get it put together and see how it works. Oh, and for those guys wondering, the 1 1/4 die is just for the lower control arms and like small miscellaneous items. It will be an 1 5/8 die needed for the roll cage for the truck. So that's pretty much what we got going on. All right, guys, so we got a serious piece in today. Got the JD squared number 3 bender. This thing is real beefy. This is a 1 1/4 die, 180 degree die I got for this thing. And right now I have it mounted up to my table. Conveniently, the main bolts on this are 3/4 inch bolts and on 2 inch bolt spacing, which I never knew when I built this table, but it will work out perfect. And conveniently, I have an extra slat here that I'm gonna use to build like a rolling stand I can put this thing on. Right now, the rolling stand probably won't work out too great just because you have to exert so much leverage on this thing that it'll probably start twisting. So I gotta figure out a way to mount it to the floor and roll it around, but pretty sweet. So let me show you how this thing works. Okay, so if you haven't seen one of these, it's pretty simple, but nice and convenient. So what you do is you're gonna slide your tube into this section here, through the follower. You're gonna insert it through this saddle, and then you're going to apply tension with this bolt. That's going to draw all the tension in the assembly. This die is held in here by this pin, And you're gonna take this section here and you use a ratcheting mechanism to rotate this whole section around piece by piece. So this has a lot of mechanical leverage. It's hard to do with just one hand. You can see I'm rotating this around, and it's going to index as you ratchet it with this piece. It's going to move this and bend it against that shoe and keep tension on here and bend it around. So that is basically how these work. Who knows? Might put a hydraulic ram on it.
All right, guys, so we talked previously about the lower control arm fixture and how this was the second iteration of it. What you see here is me cutting out a new lower plate for the lower control arm fixture. And the difference between this one and the previous one is that this one is set up for a 15.5-inch long from pivot to ball joint center, and the other lower control arm fixture was set up for 16-inch. So you see the old one there on the left, and you see the new one there on the right. The one on the right is actually shorter, and the reason this is because of the brake change that I decided to make. So the original brakes that I was looking at were a 6-piston setup from Willwood, but it was a smaller brake rotor. It was a 12.8-inch brake rotor. And if you look at this design, the rotor on this design is mounted to the back side of the hub. This is typical in some of the Mustang 2 models. What I decided is that I wanted to go to a larger brake rotor diameter, and I started looking at 15-inch 6-piston setups and started looking into those. And when I went to do my calculations, it turns out that these actually increase the track width pretty considerably. So if you look at them, these 15-inch rotors are hat-mounted rotors. So that black section you see there goes over top of the studs and pushes the wheel outward. This was not accounted for when I did the original design for the 16-inch lower control arm. And I had to now go to a 15.5-inch lower control arm and shorten up my upper control arms a little bit in order to make this work.
Okay guys, so that's basically the major update for this week. What we have going on next week is we're gonna work on the lower control arms. So I have parts coming in right now for rod ends on this, some ball joint sleeves that will be mounted up in here for both sides. And then also I got some 5/8 material in for my buddy John to turn me a shaft. He's gonna make me a custom shaft due to some of the limited restriction here. Can't actually fit a bolt head, so we're gonna use a circlip, not a circlip, a external retaining ring up here, clip ring, and then a bolt on this side to adjust the tension on it, or not tension, but slack on the lower control arm. And we'll get that going next week. And then we get to go ahead and try to fabricate lower control arms. So a lot of firsts next week. First time I'm going to be doing any tubing bending, so that'll be sort of trial by error. And then I'll also be the first time that I've done any what I consider mission critical welding. So when welding up lower control arms, it's kind of important that you get it right. Otherwise the wheel might snap off at like 150 miles an hour and you die. But you know, it happens. So we're gonna figure it out together and see how things turn out. I think that's about it for this week. So if you have any questions or anything, hit me up, leave a comment. Please like and subscribe, and I'll catch you all later. Bye.